Hello everyone, Kalispera. Thanks for being patient with us and thanks for joining us this afternoon. So Max and I are software architects working for Allwyn Lottery Solutions. We're a company that provides technology to run online lotteries around the world. And we're going to show you today how you can win $1 billion by hacking the lottery using the latest disruptive, AI-driven, cloud-native software solutions to win the jackpot. Sounds good? Yeah? Of course, I'm joking. But that was just the clickbait. What we will be doing is we'll take you on a journey through the technology of lotteries that do allow people to win staggering amounts of money and how these interesting systems work to facilitate that. We're going to talk about what lotteries are and how they work, the technology challenges that we face and how we solve them, and we're going to look at some general and specific architectures and technology that we've seen and implemented during our tenure working for Allwyn LS. So there's our disclaimer. You might not actually know how to win the billion. So what is a lottery? It's effectively a drawing of numbers, and people buy tickets in order to predict these numbers to win a prize. The more tickets that get sold, the larger the prize is, and the larger the prize is, the more people want to win. So you sell more tickets. It's a beautiful snowball effect. A draw takes place at a given date and time, and the numbers are drawn. We figure out who won based on the matching numbers, and we award prizes to winners. If you match a certain amount of numbers, you might get a smaller prize. If you match them all, then you get the jackpot. And of course, we make contributions to good causes from the prize pot as well. So let's have a look at chances of winning and the top prizes that we've seen in some common lottery games. So in Greece, the Joker, we've got 1 in 24 million chance of winning and a nice jackpot of 16 million euros. Moving on to the Euro Millions across Europe, 1 in 139 million chance of winning, but the jackpot's much larger at 230 million. Not too shabby. But then the big boy here really is the Powerball in the US. It's a 1 in almost 300 million chance of winning. You're much more likely to be struck by lightning, so be careful when you're outside. And the top jackpot is a ridiculous $2 billion. If you won that, you'd be wealthier than Tom Cruise. You could send 32 SpaceX Falcon rockets to the moon if you wanted to, and you could buy 57,000 Teslas. Again, don't know why you'd want to, but you could. And that's more than the GDP of Antigua and Barbuda, an entire nation. It's ridiculous. So looking at the user landscape in the UK, which is one of the lotteries that we run, around 70% of the adult population have played a lottery game at some point recently. And in terms of online uptake, around 25% of the whole country have played that's above the legal age to play. That's around 11 million people just in the UK. What's nice about lotteries is our user base is limited by the population of a country because you can only bet in the jurisdiction of that country. So at least we know what the max scalable load is. Some more statistics on lottery. In the UK particularly, we've seen around 6,000 logins per minute or 100 per second on a normal day, and that goes up to around 10,000 per minute on a special draw like a rollover. We sell around 3.5 million Euro Millions tickets on a good day, peaking at almost 10,000 per minute. And around half of the sales come through the mobile app, so it's a good 50-50 kind of split. And on our digital instance, we would sell around 1.35 million on an average Saturday, so it's not too bad. And even when no one wins a jackpot, we're still giving out prizes of around £2 million, where you've got hundreds of thousands of people winning a smaller prize. In terms of good causes, over an 18-year period, we gave around over £10 billion from the UK National Lottery to 250,000 various projects. This includes charities, community projects, schools, universities. So we give back to the community very heavily. And pretty much all lotteries that are run by governments or states will give to good causes. So we return a portion of the ticket sales back into the community. But it's not just a case of trying to sell as many tickets as possible. We have to be very careful around responsible gaming and people playing safely. So, we're not just trying to get people addicted to games. We have to do it very safely, make sure that it's fun and everyone's looked after. And of course, when we do make profits, these are reinvested into our games to make it fun and safe for everyone, which in turn contributes back to the good causes. There is a dark side of lottery, of course. When you've got money like that being thrown around, there's a lot of fraud being attempted. My favorite story is in 2017, one of the multi-state US game runners somehow managed to rig the random number generator. So he installed some software on one of the machines that would generate predictable outcomes on specific dates. So you could fool some of the auditing systems, and he gave some of his friends the winning numbers on particular days. He did this for years, and he got millions and millions of dollars from it. Unfortunately for him, he did get caught after about 5 years, and he was sentenced to 25 years in prison. So crime doesn't pay in the end. There's many cases like this where a retailer will scan your ticket, say, oh, no, you didn't win, puts it in his pocket, and then claims your prize for you. People try and forge tickets, so there's a lot of stuff to watch out for here. The risk for the operators is really high as well. It's a very regulated industry to try and keep people safe, and we can face massive fines if we get breached. I've seen fines from tens of millions to hundreds of thousands of euros for doing things like misinforming players about winnings, or if you don't protect problem gamblers effectively enough. But again, the fines go back into the good causes, so even there's a silver lining there. So are we just drawing numbers? Not at all. So in order to do this, we have to register players, we have to verify their identity, make sure they're above legal age. Authenticate them, we need to allow them to log into their accounts, we need to give them a wallet and fund it with some payment options. They need to pick the numbers and actually buy the ticket. We need to geolocate them, make sure they're in the country, that's a rule of play. Make sure they're playing responsibly, they're not going over limits, and they're not excluded. We need to process the draws, award the prizes, allow them to take their funds out of the account. There's other game types, digital scratch cards, Keno, raffle, all these types of things. We need to audit the system, personalize the website, threat management. People are trying to hack us, people are trying to scam us. You've got to be careful. We need to monitor the system, make sure the data's secure, report, alert, and have multiple front ends to look after as well. So it's not just drawing numbers. So what does the system look like that supports this? What's on the screen is a generic view of what a typical lottery system might look like. It's not too complicated in terms of the architecture. You've got front-end clients talking to a back-end that facilitates various features. We do rely on a lot of external providers for various things. For example, the physical draws are usually hosted by a central provider that deals with the tickets and the actual physical drawings. So we integrate with them to get the results, register the tickets, and figure out who won and who we have to pay. And there's usually many different integration techniques involved here. So we've got REST APIs, file integrations, event buses, databases, scheduled tasks, and there's always that one client who refuses to drop the SOAP API. You know who you are. So what kind of tech challenges do we face here? When prize pots become enormous, people get very carried away, and we get huge spikes in traffic. So how do we deal with this? We make sure we have a scalable architecture, we have thorough performance testing, intelligent caching, and make sure we have highly available infrastructure. If the system goes down on a triple rollover, we're in big trouble. We need to make sure the data that we have is timely and accurate, because we can face fines if we misinform people. So we have things like near real-time event logging, event listeners, scheduled tasks to keep a poke on things and make sure things are up to date. And our caching has to be quite nuanced, because if you store data for too long, you're giving people the wrong view. You've got to keep it up to date without impacting performance. There's many external integrations to deal with. So we try and stick to common integration patterns. We have functional separation of services to keep everything discrete, and very thorough end-to-end testing without going too far overboard. And we have a big emphasis on security by design, adhering to best practices like OWASP, regulatory requirements, and we have a lot of developer training on how to code securely. So I want to talk about our architecture journey over the past decade at Allwyn Lottery Solutions. So pre-2016, we're all about the UK lottery. It's a nice big project. 2017, we got one of the Swiss lotteries, Lotterie Romande. 2018, we got the Illinois State Lottery, which again, nice big piece. And in the future, we're looking at more US-based lotteries. So what do the architectures look like for these various projects? So the UK lottery is the original monolith for me. I wasn't involved in it, but I look back at it. and it's a very interesting code base, let's say. This is a huge oversimplification of it, but it's effectively an enormous monolith. We've got back-end business logic in one huge chunk and an integrations layer below that, talking to all of the third parties. It's very simple to deploy, but it's very hard to scale. It's quite complex internally, so it's doing lots of things, too many things for sure. But there is less cognitive overhead to sort of maintain it and introduce new features, because you're only looking at one code base, albeit a complicated one. Moving on to the Swiss lottery, this is where we got a bit crazy. We didn't decide to reuse the UK project because it was too bespoke for the UK. And we went a bit crazy with the microservices. Every single possible functional area was a different microservice. We had one for player accounts, draws, prizes, all of these things, too many to count, needless to say. So the lack of reuse and it being a greenfield project meant that the kind of ramp-up time was enormous. And of course, with Conway's law, the software will mirror the organizational structure. So we had a team taking care of a couple of services here, a web team, an app team, a few more teams added in here and there. Before you know it, you've got 10 teams, and it's very, very difficult to manage this. It was a little bit crazy. A very exciting and fun project, but architecturally, it was perhaps not the greatest. We went big on REST APIs. We went for Cassandra, even though what we really needed was a relational database. And we had many, many integrations. It was kind of a mutant rather than a hybrid because we had just everything going inside it. Moving on to the Illinois architecture, we went completely the other way. So we took all of the microservices, we threw away the things that weren't relevant to the US market, and we mushed them all into another monolith. So we tried to learn from our mistakes with microservices, but perhaps we took it too far the other way. We did reuse a lot of code, which meant the ramp-up time was a lot shorter. The deployments are very, very simple, but with a heavier overhead, heavier footprint. The team is much smaller that gets to maintain this, and it's got quite nice modularization within the monolith because it was comprised of original microservices. So it's quite nice to work on. It's a good code base. For the future, what we're looking at is finding that kind of Goldilocks zone, where we're not using too many microservices for the hell of it, but we have great domain distinction and good modularization across services so that we can scale independently. We still get our reuse, so we're looking to find that happy middle ground. Will it be the right move for us? It will remain to be seen. So what did we learn from this? Don't chase the shiny new toy. For us, this was microservices. Venkat mentioned it yesterday as technology infatuation. I think that's a great term for it. We should have stopped and considered whether we needed the microservices or not. Making reuse of what you can, again, not using the UK code base was just slowed us down immensely. So if you can reuse code, even if you have to inherit some dodgy tests, perhaps it's worthwhile. Being pragmatic instead of dogmatic. We had a leader at the time, I won't name names, but he was very dogmatic about us using Cassandra because it was the latest and greatest, fastest database on the planet. It's not what we needed. We didn't need a Lamborghini to do our weekly shopping. It wasn't the right tool for the job at the time, so we should have been more pragmatic in our technology choices. Conway's law, something to watch out for. If you find that you've got too many teams spinning up, maybe you need to look at your architecture and figure out if that's correct. And vice versa, if your architecture is crazy, consider the team structure around that. And just be very careful starting with microservices up front. You might not need as many as you think. So I'm going to hand over to Max now. He's going to tell us some stories about what it's like building the player-facing parts of a lottery system. So over to Max.
Thank you, Phil. That was really, really great. Thank you. Thanks. So, from all the things that Phil mentioned in the beginning of the talk, what do you think we aim to keep top of mind while working on our lottery apps? Well, lotteries have the potential to impact the lives of their users in ways that few other industries can. So it's a huge responsibility for us working on lottery systems to make sure we are getting things right. This extends from the infra and back end all the way to the front end apps that we work on. For the front end specifically, I can tell you a few stories that I think illustrate this really well. So a number of years ago, I was working on a WebView-based iOS lottery application. The app had a feature that allowed users to scan a QR code on their lottery ticket, and it would show whether the ticket was winning or not. Over the course of months, we started getting intermittent reports to the call center that this feature was sometimes showing the wrong results. Looking to fix this, we scoured the code base. We wrote additional tests, tried to reproduce the issue, but try as we might, we weren't able to find the bug. It was doubly difficult because not even the users who reported the issue nor the call center that was helping them were ever able to reproduce it consistently. A true Heisenbug. But every couple of months, a new report would trickle in, so we knew we needed to get to the bottom of it. At this point, we decided to rework the error reporting around the scanner. We added real-time logs and built a system to revalidate the results the app was showing to players. And so, finally, we started getting hits. A tiny percentage of the logs indicated a different result in the app and a different result in the independent validator service. And it's here, one of these hits, that really stuck with me, because I feel it tells such a simple story of emotion. From the logs, I saw that a user, anonymized of course, launched the app late one night. They then navigated to the ticket scanner and scanned a few tickets. The last one was a winner. I don't know how much, but it might have been a good amount because they spent a while on the results page. They then put the app into the background and probably went to bed pretty happy that night. Now, if you had found out you'd won the lottery last night, what's the first thing you would do in the morning? That's right. I think you'd want to have one more look at the number, just to make sure you weren't dreaming. And that's what this user opened the app to do. But when they scanned the ticket in the morning, this time, it showed up as non-winning. They must have been absolutely shocked. From the logs, they scanned their ticket again and again and again, at least 5 times. And each one came up as non-winning. I cannot imagine how they must have felt. Like a punch in the stomach, probably. Thankfully, they remembered the age-old saying, "Have you tried turning it off and on again?" And they closed the app and restarted it. When they navigated to the scanner and scanned the ticket this time, it finally came up as winning again, which must have been such a relief. When iOS is under memory pressure, it might sometimes release the memory used by backgrounded apps, especially web views, meaning that the app is eventually brought to the foreground again, and the web view will reload. In this case, the app reloaded on the ticket scanner screen, and unfortunately, because of the way the app had been architected, this meant that some crucial context was missing. Under normal usage, to get to the scanner, you always needed to have navigated via other screens. You would never load into the scanner directly. These other screens contained calls to fetch some of the data needed for the scan. The app did not handle the missing data gracefully. Instead of raising an error, essentially it assumed that since there is no data, that must be because there are no winners. And so it just showed the player that the ticket was not winning. It goes without saying that we re-architected this and similar interactions within the application. And I'm pleased to report that since then, our logs have not caught any other similar emotional roller coasters. Now, this may have been a simple story with a happy ending, but I think it showcases the real emotional impact that our apps can have on people's lives. But like Phil said earlier, bugs in lottery apps don't only impact the players, but also the way the business operates too. The process of developing a robust lottery client app can sometimes look very different from what it takes to build similar systems in other industries. The incident I mentioned just now was not the only incident with the scanner and its data fetching. In a previous case, a fairly simple code change introduced a race condition in a JavaScript promise chain that severely impacted our business. Before the code change, the app startup looked something like this diagram. The app starts up, triggers a few critical network calls, and is only initialized successfully when all network calls complete successfully. After the code change, one of the network calls was disconnected from the promise chain, and thus app initialization was considered successful even if this network call failed. So, anytime this network call failed during the app startup sequence, the app would launch in a corrupted state, again, leading to incorrect results in the scanner. The network call did not fail often, but as with any network call, it failed often enough that this time the bug affected a large percentage of sessions. The decision was therefore taken to completely disable the scanner until things had been sorted. Surprisingly, perhaps, despite the fact the bug was fairly easy to identify and fix, we didn't re-enable the scanner nor release a new version of the app for the next 4 months. Before we did, we wanted to make sure that it would be difficult for a similar problem to slip through again. So, we reviewed the app's code base for similar problematic patterns. We re-architected the startup sequence. We added automation coverage for areas that were missing it, and had 2 separate companies performing rigorous suites of independent QA tests before we were happy to go live with a new version of the app again. For lottery applications, a lot of investment goes into correctness and accuracy. Not only did all this cost the lottery money in engineering hours and depressed revenue from the mobile application, but as Phil touched on, lotteries are heavily regulated, and every incident like this is immediately reported to the regulator, and the regulator does fine the operator for every serious incident. In this case, I believe the fine alone was near 500,000 euros, while the missed revenue was in the millions for just this single code change. It is for the emotional stories, like the one I mentioned previously, and the economical impact like this, that we spend more time than might be industry standard on quality assurance. A multifaceted approach is critical, and so our release process at Allwyn includes all of what I already mentioned before, and a few more things. From robust processes and customer support, security reviews, type systems, feature flags, continuous integration workflows, to penetration testing, and careful, often week to month-long QA pre-release and post-release cycles. These processes are continuously evolving and improving, and have got to where they are today within Allwyn as a result of numerous scars from previous battles. Robustness is important for lotteries, affecting both players and businesses. But would you be surprised to also find out that we face industry-specific challenges from the platforms and partners we work with? Indeed, because of the impact the lotteries have on people's lives, other businesses we rely on are also careful about how they support our use cases. Apple and Google have special provisions for lotteries in their App Store guidelines, and they do not, for example, allow any usage of Apple or Google in-app purchase APIs within lottery applications. One fairly recent case I can tell you about that really affected our business, and we ended up having to make big updates under very tight deadlines to every single client app we supported. A few years ago, Apple updated their guidelines disallowing lottery apps from using remotely hosted HTML5 content for specific interactions. They required that, for these use cases, the code executing inside the web view must be embedded within the application. Now, rumor has it that there was an incident with another lottery app using a remote server that was selectively showing different content in web views to Apple app reviewers and different content to end users. This is a bit like what a certain German car maker was caught doing to their cars to pass emission tests, if you remember. I think this really pissed Apple off. In any case, our apps usually cater for 2 primary use cases: Draw-based games, which is like buying a lotto ticket, and instant games, which is like buying a scratch card, existo. We support catalogs of hundreds of instant games that are hosted on web servers and shared across web and mobile as HTML5 games. We confirmed with Apple that these HTML5 games were affected by the rule change. And so we quickly had to find a way to continue supporting our catalog with games that would be embedded within the iOS app binary. Redeveloping all games using native technology would take months and cost thousands of euros per game. So this was both cost and time prohibitive. And each game was between 3 to 8 megabytes in size. So simply bundling all of them up within the app code would make our app size balloon to almost a gigabyte, which was prohibitive if we wanted to keep our users. So thankfully, Apple has an API called On-Demand Resources for adding non-executable app assets to the app package delivered for review. Apple then splits these packages from the core app binary and delivers them separately to users' devices. The app can then request a resource from the API when it needs it, and the resource will be downloaded and cached on device. Since JavaScript, CSS, and HTML count as non-executable app assets from Apple's perspective at least, we were able to use this API to bundle the HTML5 games within the app without significantly affecting the installed app size. It was a big challenge putting it all together, and the business needed to quickly learn new processes for properly deploying new games across web and mobile, but we were able to get things done. Now, I hope I haven't dissuaded you from working on lottery apps with these stories, because they are great to work on, and actually in many other ways, building lottery front ends is quite similar to building any large-scale e-commerce shop. As Phil also touched on, you'll find all the usual e-commerce suspects: authentication, registration, account management, buy journeys, shopping baskets, and favorites, promotions, cross-sells, upsells, personalization, and optimization, CMS and CDN integrations, push notifications and messaging, analytics and telemetry, security features and bot prevention, and more. A few more that are a little less common in e-commerce shops are geolocation and geofencing. Lotteries are almost always restricted to a specific country or state. Funds and wallet management. Lotteries pay money out as well as receive payment for players, and the best way to manage this is usually via wallet. Gameplay, as mentioned in previous stories, there are numerous aspects of gameplay that can be a challenge for lottery developers, including the ticket scanner and the instant games we talked about. And of course, responsible gaming. Being able to set personal limits to how much you can buy is not usually what you expect to find on an e-commerce store. But for lottery apps, this is of course a critical feature of player safety. Now, those are the broad strokes in terms of features and in terms of technology, like with the backend that Phil mentioned earlier, we've gone through many iterations on what approach and stack we choose to build our front-end apps with. For web, Owen started out with free marker templates and simple JavaScript. But as the front-end development teams got larger and the web apps grew more ambitious, we transitioned to JavaScript frameworks like Vue and React. This has allowed us to optimize our development tooling separately for our back-end and front-end code bases, and means our teams can be more efficient and better focused on their core competencies. Although we've managed to separate front-end and back-end, we still encourage our teams to have a full-stack mindset and not to be afraid to dive in and contribute in any repo. Sometimes being able to unblock oneself is the most important thing. We follow a similar process choosing our tech stack on mobile. Depending on the needs of the specific lottery we partner with, we've worked with everything from web app wrappers and hybrid apps using Cordova to React Native and even full native. I will say that each approach has its pros and cons, and as usual with engineering decisions, there is no one right answer, but the choice very much depends on the individual case. Web app wrappers are a lot faster and cheaper to build and can provide a good amount of functionality, but at the cost of a generally worse user experience. whereas full native can be much more costly but allows for true platform-specific optimization. If the timelines permit, we found that choosing React Native for mobile is currently giving us the best of both worlds. React Native gives us a good developer experience that allows us to build across mobile operating systems with a single code base, and we've also found great benefits from sharing expertise and tooling with our web teams that are using React on the front end. Now, I think Phil and I could both go on for hours about these systems, and there are hundreds of little details in every area you can imagine that we haven't touched on. But I think our time is close to up today, so I think I'll wrap up now with a quick summary. In general, online lottery systems are complex beasts, with many interesting technology challenges to overcome, covering a wide range of functional areas and ensuring high availability during critical periods in order to ensure players can safely have fun while attempting to win staggeringly large prizes, all the while contributing to highly charitable causes. Well, that's great, you might say, but I only sat here listening to you for the last 45 minutes because you promised to tell me how to win $1 billion. Well, for that, unfortunately, from the clock I can see here, our time is up. So you'll have to come and talk to us after the talk, and maybe we'll find some numbers for you. We'll see. Thank you very much. Thank you.
Gents, thank you ever so much. That was a fantastic presentation. You completely destroyed my confidence in the Greek prize scanner app now. You should know that. It's like, also free marker and jQuery. It's like, I got shivers reading this. If you need to find the only one single person in Greece who actually enjoys working with free marker and jQuery is me. It's time for lunch, everybody, but do we have any questions? I know I have one, but is there anybody else? So feel free to just go to lunch. I do have one question, gents. Let's assume I won the lottery. I was always curious, is there a workflow? Is there an email template that gets fired where it says, congratulations, you're a jackpot winner? Is there a notification that comes on your phone? So can you answer that? Is that something you can answer? I win the lottery in one of the lotteries you manage. And you only know me because I'm an online presence. Okay, I've done my KYC, you know who I am, you have an email. What happens then?
Thanks. Yeah, so I don't know all of the details because it's not, these are some of the processes that other people work on, and maybe Phil can fill in anything that I miss. But the quick answer is yes, of course, we've thought about these things. And actually, although it doesn't happen to you often, it does happen to someone. It happens often. You know, like people win big prizes very often with these lottery apps. And it just doesn't happen to an individual very often. So in terms of processes, there's multiple tiers typically. So if you win small amounts, it automatically gets added to your wallet. If you win larger amounts, you have to manually claim the amount for it to get added to your wallet. All of this, you'll get a message, you'll get notifications, emails, follow-ups, and so on if you don't interact with it. And then if you win the biggest prizes, then again, you need to call the call center and do things like that typically. Now, what I will say is that if you're not buying online and you buy a retail ticket, and again, this depends on the country and so on, but often retail tickets don't have that because you don't have a name associated with the purchase. So I don't know who you are, who bought it. And that's why you can do things like what Phil mentioned earlier, where the actual person checking your ticket can then say, oh, you didn't win, and take it from you. And actually, yeah, I'll say very quickly, there was a story a long time ago. Retail tickets, they expire after 180 days in some jurisdictions. So if you don't go and claim your money, 180 days later, it's gone. And this happens more often than you think, which is a bit sad. But there was someone who took advantage of it. He would wait until the end of the 180 days. No one came to claim it. He's like, no one's going to come and claim it. What am I going to do? I'm going to print this ticket. I'm going to print and I'm going to go and claim it. Again, like Phil said, they caught him. So, don't try this at home. But, but yeah, these are the types of things that we have to deal with. Thanks. Was there anything you want to add?
Do you have any more questions? Questions, anybody? All right, in which case, thank you ever so much, gents. And time for lunch, everybody. And see you all back here